right, there's just a few more things to go over on here. What I did during the break was I created a real simple little program, and I'm going to show it to you later. And again, I'll save it out there. It'll allow me to show you a few different things. What they talk about next in section 3.6, which starts on page 151, and it goes on really for several pages, all the way through the middle of page 158, is they talk about formatting numbers. And the example they have in the book here, if you do this, so this is creating a variable. This is a decimal variable. That M that's there means that it's decimal. All right. But the point is, notice the number, pretty ugly. 1, 2, 3, 4, 5, 6, 7, 8, 9, period, 4, 5, 6, 7, 8. If you print that number out, it'll try to print it out like this. But if it's meant to be a dollar amount, if I say, when you print it out, this means take that amount, convert it to a string, and then format it to currency. So it'll put the dollar sign in, it'll put commas in, and it'll take this and it'll do whatever it has to do to make it 2 decimal places. Does that make sense? Now, what if I wanted this and it was the decimal number, but I don't want the decimal, or I'm sorry, I don't want the dollar sign to print out. Okay, so I want everything, but not the dollar sign, and I want it to 2 decimal places. Then I say N2, number with 2 decimal places. Now, all of that stuff is really explained, and they show you some examples of it. First, in the table that's on page 152, these are the different formats that you have, and then they show you an example of each one of them. All right, and this is a really good example here in the table. That's table 310 that's on page 153. And you'll notice when you look at this, you maybe can't tell right here, but it will round for you too. All right, round up or round down. So it'll round up if it's less than 0.5 on here, and it'll round up if it's greater than or equal to 0.5, round down if it's less than 0.5. All right, I just don't want to spend a lot of time on that. They have this sales calculator program that's on here, and it's not a bad program at all. Again, if you're struggling in here, I'd suggest that you take some time and you look at these tutorials, because that code is there on the P drive. All that code, so the code that you see on 154, 155, and really the codes on 156 and 157, all that code is out there on the P drive. All right, but they explain it and they show you it, and then they show you how you can come in here and notice you put in here 120. All right, so it's 100. You're buying something for $100. You get a 20% discount, so it's $80. And you notice they formatted that for currency. All right, very similar to what I just showed you. There it is. Again, you're going to get more out of this by just practicing it and doing it. That's all. That's all I can tell you. All right. Next, what I'm going to do is I'm going to go over the material that's on. Starts on 159, and it goes all the way through the middle of 166. We're going to go over that first, then I'm going to bounce back to the little program that I wrote during the break. Okay? So, an exception is a bad thing in programming language. It's an exception to the norm. All right? You know, years ago, we had a student here, very nice gentleman. All right, but he was older, set in his ways. When he graduated from here, he was in his 40s. I don't mean to say that's old, but it's older for a lot of our graduates. And he went in for a job interview, and he was primed and he was pumped and he was ready. And the next day I saw him, and he had his head down, and I said, "Well, what happened?" He said, "I don't know. The interview was going really well." And I said, "Yeah." He said, "Yeah." Then they asked me if I'd ever seen their website, and I said, "Yeah." And there's a lot of problems with it, and I spent the next 10 minutes telling him what the problems were. I said, "Well, that probably didn't help you in the hiring process." And literally, just why? Because when you get hired at a place, to get hired, you want to fit in. If you decide that you know more than they do about web programming and you want to change their website, wait till you get hired and you've been there for a while and you've made a name for yourself. All right? And the same kind of thing in here. You want to fit in. You want things to operate normally. When they don't operate normally, you get an exception. Now, just to show you this real quick, we'll come back to it, but this is the program I wrote. You run it, And what happens as soon as you run it is it's generated a random number between 1 and 10. Okay, so notice if I put 5 in here and I click make guess, it says that it's too high. I really should have put it in here, but I don't know why I used a message box, but I did. All right, so if I do it again and I come back in here and I put in a 3, still too high. So I know already looking at it, it's got to be a 2 or a 1. How about a 1? Okay, that's pretty neat. Okay, I guess I didn't set it up right. It should have been 1 to 5, but it takes 0. The point is, when I run this, what do you think is going to happen when I click right now? I'm going to get an exception because it's trying to do an int.parse on a blank field. It doesn't know how to handle it, so it gives me an exception. Here it's called a format exception. This is one thing we looked at in the program example that we did before the chapter. All right? So there's a lot of things I'd have to do to fix this thing up. But one of the first things I'd want to do probably is not do this by itself, because I have to check to make sure I didn't screw it up. All right, all these things that say message box.show, I can fix this real quick to change that to text box. I think it's status dot text. Hopefully that'll fix everything. You notice this? If I go and paste something in and I make a mistake, and it's caseness like you see all right here, all right, that's what the problem was, then I have to manually go back in and change it. But if I'm typing it in, so if I were to come up here and just type in this, text box, guess, dot, see how it changed it for me automatically? All right, so there is some advantage sometimes at least to using the IntelliSense. I'm not sure, I thought that had to be a capital, but maybe it is a lowercase, I don't remember. Oh, equals, too low, equals too high, and equals, you got it. Now hopefully, just with this simple example here, a couple things that you see right away, and that is, well, I'm going to have to make a guess in there, and I'm probably going to want that guess to what? I'm going to want that guess, I would think at least, to be a number. And I'd want that guess to be not only a number, but a whole number. How many fingers? 3.5. You know, that's not going to make a lot of sense for this particular program. All right? So there, although it's not wrong what I've done here, I'm not really checking it for errors right here. So when you start to think of, well, what do I want to do? All right, and I'm surprised. I thought with 1 and 5 like that, that's what it would give me, and it might be. I might have to add 1 to it. I don't worry about it right now. But the point is, what I probably end up doing is this. I'm going to say it equals 0 right now. Then, if you remember this from the other day, I'm saying here try. So try to do this. Try to say this. To say guess equals this. Try to do this. Try to do this. Try to do that, etc. So everything I'm doing, I'm sticking inside of what's going to be called a try-catch block. And then catch, and I'm going to say number format exception. I thought that was what it was. Maybe it's just a format exception. All right. So try to do this stuff. If it fails, all right, what I'm going to do literally is just say message box dot show you didn't use a whole number. And I'll say return, and no matter what they put in there, I want to take what is in there and clear it out. So I'm going to say text box guess dot text equals double quote, and we'll give it the focus. So notice how this has changed. Now I'm leaving it blank. You didn't use the whole number. All right? But the program didn't blow up because I put exception handling into it. It'll now handle it too if I put something non-numeric in it. You didn't use a whole number. All right? And again, now I can put in 345, and I'm going to guess right here it's going to say too high. And notice it says it in here now. All right, and I can come back in here, clear that out, but now it made a new number, so but that's fine. So I'll come in here and I'll say 5. All right, so that still works. But what I'm trying to get across to you here, I guess I didn't put any code in there for exit. All right, is the fact that when you want to start to do what's called idiot-proof your program, and it's called idiot-proof for a reason. You put it within a try-catch block. So within this try, you put in all the code that could possibly fail. And you go, well, what, this stuff couldn't fail. Yeah, you're making checks right here. And I'm not taking any chances, but the big statement is that one. If that fails, it'll fail because I put in something that wasn't formatted correctly. It wasn't a whole number. So I'll go down then. If this fails, I'll come down and I will do what's in here. So either the program will be fat and happy. It says, guess, I put in a 5. Is that less than the number? No. Is that greater than the number? No. Is it equal to the number? Yes. So it should put, you got it there. I run it again. It asks for the guess. I put hello in there. It attempts to do this. It fails. So it does not go on and do this. It jumps down here and does all this. So again, we're trying to idiot-proof the program. I thought it might make a little bit more sense to just write something in front of you, and I screw it up enough when I do it like this anyway, so I show you some of the errors you're probably going to end up with. All right, but it's just a simple little program that really doesn't do a whole lot. Okay. Now, this is not very different from the stuff they're showing in the book. So they talk about exception handling. So there's an example. Enter the miles driven, 300. Enter the gallons used, WXYZ. And the program blows up right there. And it says format exception because it tried to take the string, which was WXYZ, and format it as a double, and it couldn't. So it gave you an error message. So again, how do you handle it? With try-catch. You can have multiple catch statements. So I could have had another catch below this if I wanted to. All right, and I think I showed this to you the first day, but on the off chance I didn't, or you weren't here, or whatever, that, of course, as you all know, so if I come in here and say Google, and I say C# exception handling. All right, all I want to show you is when I look in here, almost always what you're going to see for either the first result or one of the first ones is something from here. msdn.microsoft.com. MSDN is the Microsoft Developer Network. It's kind of the key to everything that you'd want. So if you don't know where to start, a lot of times just going out to msdn.microsoft.com is a good place to start. It pushes you off a little bit, but in here someplace, when you get into it, there'll be a search box up near the top. And you can go look through it that way also. All right. Sometimes I can say it to people, I'm just going to Google it. Okay. So it's very similar right here. So what are we doing? Try, and notice after the catch, they didn't put anything at all in there. I like to, when you put catch, typically you put in the type of exception that you want to catch. That's why I put format exception. All right. This will work, and all this does is it says invalid data was entered. Well, I don't know if that helps a whole heck of a lot, but you'll notice in the example that I gave you, and I'm going to run it one more time, and again, I'm going to put in here 25, not the number, but the string. So to me, it's nice when you do that to not only give them a message, but also, look in the box there, clear it out and put the cursor back there. Make it as easy as possible for somebody running the program. If they keep doing this, again, there's a word for that, and it's stupid. I mean, it is. If somebody just keeps putting bad stuff in there, but you have a hard time accounting for that. All right? So normally this is the way that a program would be written. It would be something like this. So they go through a lot about displaying exception messages, etc. All right, and let's see. I'll do this too. I'll add this to it just so you see it. All right, so right now what we're saying is this. We're saying you didn't enter a whole number, but I'm going to add to that. I'm going to put a couple blank lines in here, \n for blank lines, and then I'm going to add to that plus get message. What was it? Dot message. All right. So notice how this changed now. I'm going to put something non-numeric in again. I'll leave it blank. It says you didn't use a whole number. That's my message. Input string was not in the correct format. That's the message the system gives you. So the first time I ran it for you, I gave you my message only. And the second time I ran it, I gave you my message and the system message. If I want to be more terse, I can literally just come in there and not even put my own message in there. Just put in the system message. All right, that's totally fine to do that. So now, all it says is input string was not in the correct format. Right. Again, all of that stuff that's there is shown to you in the book, and there's examples of it on pages 158 through 166. All right, there's the same message that you just saw. They do a test average thing, and always try to go over this and bring this up to people. It sounds simple, and if I do this and you go, well, duh, good. All right, let's assume that somebody did 3 tests. And for now, even though they're crummy names, we're going to give them A, B, and C. So we're going to say int A equals, they got a 71. Int B equals, they got an 81. And int C equals, they got a 97. Okay? I want everybody to understand, if you do this, their average isn't going to be about an 80-something. Remember, if you do that right there, what this says is take whatever's in C, which is 97, divide it by 3.0. All right? So 97 divided by 3 is going to be about 32. So it's going to take 32 and add to that 71 and then add to that. All right, so it's going to be wrong. So we want to do the division after we do the addition, so we need the parens. All right. And they show you that in here, and they mention to you. So this is actually not a bad little program that they have here in the book. Page 162 it looks like, and it's a test program. But again, when you put that in, it's also possible that you'll leave it blank. Maybe they weren't there for the test or whatever. So they put it inside of try-catch. All right. And again, the author, I think, at least does a pretty good job of explaining what's going on in here. I've shown you a couple of other examples. And again, I'll fix that one up and throw that one out there by the end of the period. Constants, we looked at this the other day also. It's the word const, followed by the variable type. It's kind of an unwritten practice, or just that people do it, that constants are in uppercase. I don't like it with interest underscore rate. I'd still just run it all together, but if it makes it easier for you to use the underscore like they show it here, this is on the bottom of page 166, then do it that way. All right. When I was working on this little program that we've been looking at, this one, before class, all right, when I created the random number, if you take a look, there is where I'm telling it to work with the random number. So I'm declaring, and don't worry about random numbers, we'll get to this in a later time, but I'm declaring what's called a new random class right there that's called random, and I'm creating a new a variable there for random number. I want to be able to use this in multiple routines. So if I declare it at the top of my program, right under where it says partial class, and now it's available, notice if I come in here, and I come into this form how many fingers. All right, And if I type in here, random number dot, you can see that it recognizes it. I'm not getting an error message. Or if I come in here, if I said equals 21, all right, I don't get an error. I can put that line of code any place. All right, so I've got one here and I've got it there, but I could put it anywhere I wanted to put it, except I can't put it before, so I can't put it out here because I didn't declare it until down here. Right. So they go through a big, long to-do, so to speak, in here, declaring variables and fields, and a thing that's called scope. And scope just means who has access. If you declare a variable inside of one of these routines, inside of a click event or whatever, it's only available in that event. All right? Until we get to a later chapter when we talk about passing variables. Another thing here that's like a coin change counter application on 171, 172, 3, 4, and 5. I'm not going to go over any of that stuff. All right, I'm going to jump all the way to page 175. And they talk about the math class. All right, you may or may not remember this, but the other day we went over that BMI example. All right, and we said something like BMI equals weight times 700. This might even be the wrong calculation. I don't care, but this is what I want to show you. Divided by, whoops, divided by, and I put first in there something like this, height times height, okay? And then I changed it. So instead of saying that, we said this, math.pow, height, comma, 2. Now, you can look at that and say, you know what, I like the first one, there's less typing. But what if instead of saying height squared, it was height to the 8th? Now, I'm typing this as opposed to times height times height times, and I got to put it in here 4 more times. I'm going to run a room, so just let me throw it, whoops, let me throw it. I don't know about you, but I'm not going to type that when I can type this. When I say math dot, what I'm doing is I'm using a built-in class in this language that's called the math class. It's got a bunch of stuff that I can use. Like what? Well, if I come back to my program here, and I just come in here and I type in as an example, where I've got this in the click event, that's fine. I'm going to say here, math dot, and you notice there's a bunch of stuff that's already available for me. Now, a lot of this stuff is geometric and trigonometric, etc. Probably don't care. Sines, cosines, etc. Right. But there's a few other things in here that we'll look at as we go on. Things like floor and ceiling. And one of the ones that should be in there, there's math.pow. All right. So if you want to learn more about some of that stuff, you can look on the bottom of page 175. And on 176, there's a nice little chart there. It's by no means a complete chart, but they show you some of the things in the math class. It says many of the math classes methods. Okay. There are some built-in math constants. Math.pi. That's already set to 3.14159. I don't know how many decimal places it goes out to. And E if you're doing logarithmic types of calculations. If you don't know what that is, you won't need to for this program. All right, but you can read about it if you want to on page 177. All right, next they talk about the tab order. We've already done that. I showed you that earlier. You know what this is. If you weren't here the other day and you're confused by what we did, all I said was if I go and click View and go down to tab order, I can set the tab order. You know, now notice now, you can tell I put the buttons in first, then I put in the text boxes, then I put in the labels. So I can change that to 0. I want that to be, let's make it 0 again. 0, 1, 2, 3, 4, 5 and 6. All right. Then do another view tab order, and it goes away. Notice now if I run the program, tab order is set. There it is, 0, 1, 2, 3, 4. Again, you can't tab technically to labels, as we talked about earlier. Also in this program, I showed you this on one of the examples. Okay. If you set the focus, that means put the cursor there. When I'm running the program, I can, typically these are the only two things that are going to get the focus. But what I wanted to make sure was if you screwed up and if you typed something bad in here and you clicked that button, you removed whatever was in there, but I wanted to make sure my mouse was there. That's called setting the focus. And that's what they mentioned on the bottom of 179 and going on to page 180. All right. On 180 and 181, the author talks about access keys. You may or may not know what that means. All right. First, let me put some code here. I'm going to just use the cheesy way, the this.close for right now, just so there's some code there. All right. And then I'm going to come back here, and you probably have seen this before, but now where I've got the actual code that I type in there, instead of EXIT, I'm going to put E&XIT. And you may or may not be able to tell, but that X now has an underscore there. All right. So if I run the program, I should be able to do an Alt X and it stops. All right. That's an access key. Okay. And they show you how to do that. That's the ones you use most often. But if you look up here, Microsoft, all right. Well, I guess they don't show it, but they provide access keys for all sorts of stuff. That's on 180 and 181. On the bottom of 181 is the accept and cancel buttons, which I've already shown you. So I'm not going to run through those again. On 182, they talk about the back color property. I've already shown you that. So back color is your background. Fore color is the color of the text. You can set it in code, so there's a lot of ways you can set it. So far, we've just set it from the properties window. Background images for forms, you can do that if you want to. So if you want your screen to look, for example, something like what's shown on 184. Okay, so if you wanted that to be your background image, you can do that. I'm not going to go into that right now. All right. We've looked a little bit at the picture box control already. And the only other thing that I'd mention that's in the chapter, just so you see this, if on this program right here, the one that I showed you, if I had wanted to do this, let's suppose for whatever reason, I want these buttons to be in what's called a button group. So I want them grouped together. All right. I can come up here, and one of the controls that I have is something that's called, it's in here someplace, it's a group box. Of course, I can't find it right now, but I know it's a group box. There it is. So if I come up here and I put a group box in like this, all right, I can move it around to where I want it to go. Okay. Now, hopefully it's going to let me do this, but we're going to, whoops, we're going to find out right now. Normally what you do is you create the group box control like this, and then you create other controls and drag them in immediately. But I'm attempting, even though I've created those controls already, I want to drag them in after the fact. So I'm going to grab all three of these and see if it's going to let me drag them in. Yep, it did. Good. Now, did that do anything? Well, it doesn't really look much different. You could even argue and say, yeah, it looks worse, Jeff. Okay. But I can come up here, and this isn't a great example, but I just wanted to show this to you. But by making this group box, now I can come up here and I can change the text to buttons. And you may or may not be able to tell that changed to buttons, but they're now in there. Sometimes what you do, it's kind of like setting up a field set that you have in HTML. So if I wanted to put a bunch of information in here and I wanted all my name, first name, middle name, last name, address, city, state, zip, I could put it in a box like this. It looks a little different too when you run it then. You still see that, and they're all inside of there. All right? And that's pretty much it for the chapter. So one more thing, and then we're finished. Okay? And what that one more thing is I want to go over and have you see this is out there on the P drive. This is out there on Blackboard. All right? In fact, I'm going to grab the one that I've started manipulating already. I'm going to grab the one from the P drive. All right. Don't worry that I said it was assigned Monday, all right? Because you still have 2 weeks. You have 2 weeks from today. I want that BMI one that we did as a class, so if you weren't here, you'll have to watch the tape. All right? I'm not doing them and then saving them. Why would I do them and save them and then tell you to hand them in? That wouldn't make a whole heck of a lot of sense. So I want you to do the BMI one. That is number 6 on page 193. So if you weren't here the other day, this is the one that we did as a class. All right, it is out there on the system, but I want that one done. Okay? In addition to that one, you are going to do number 2, which is called tip, tax, and total. And number 2, it's actually much easier than the one we did as a class. It's right here. Create an application that lets the user enter the food charge for a meal at a restaurant. When the button is clicked, the app should calculate and display the amount of a 15% tip, 7% sales tax, and the total of those amounts. What I'd like you to do on that, it's not shown on here, but I'm saying it, I'd like you to add that exception handling to it. All right, I've just shown you how to do it, and I put a couple programs out there. All right, so I will come back to this. All right, so tax, tip, total, assigned, and I'll put in here with exception handling, and I'll have to update the one that's out there on Blackboard. Okay, so you will have lab all next week. Try seeing how much of it you can get done by yourself. If you run into problems, you'll be able to come in here Monday or Wednesday of next week and ask me or ask Ben back there or ask John. All right, they both know the language very well, and that's what we're here for. All right. Also, just so you know, as far as the other stuff, so to speak, that's out there for that. So on the P drive, not there. These are things I want you to get used to doing because they're just good programming practices. All right, so under the homework, notice I've got my executables, so there's my BMI right there. And there's my tax tip total. I don't remember if I put, yeah, I even put exception handling in there. So if you need to use something as a guide, yours does not have to look like mine. Make yours look whatever way you want to make it look. All right, you're not impressing me by making it look exactly like mine. You're not. I'd rather have you do what you want to do, but don't get so enamored with the interface that you don't write the code, please. All right, so you've got those executables out there under the homework folder, the comments that each one of them needs. So there's the BMI or the tip total, tax, whatever it is, and there's the BMI one. So you can paste those in. I'd like you to have a little prologue somewhere near the top of your program with that stuff in there. I'd like you to use good variable names. All right, not X, Y, and Z like I showed you before, but something that's reflective of what you're trying to do in the program. Questions on that? Anything that doesn't make sense on there? So again, it'll be lab all next week, and the programs, both of them will be due 2 weeks from today, and 2 weeks from today is the 11th. So next week will be lab all week. When you come back on the 9th, that Monday, we'll start on Chapter 4. We will again we'll take that BMI program and we'll add some if statements to it. So you can see that stuff. All right, then you're going to have, we'll do the same kind of thing. Then I'll lecture on the Wednesday. Then the next week will be a lab. Get the pattern? Because we're going to keep that up as best we can for the rest of the semester. All right, that's all that I have.